Well, hi everyone, David Cross with you today, and it's been a while since I left a Node-RED video out there or on any of the projects I'm working on. And so I have been working through an evaluation series of videos and decided that I wanted to do a separate custom project in my lab server to kind of go through some functionality in DNS that is of interest to me, which they refer to as called DNSTAP, and is the ability to record basically DNS transactions, queries, responses, and then from the server and the client perspective. And so I've been diddling around with how do I read this information and make it presentable, and then a way that I can work through any type of web browser or create an API that I can interface into my external applications like VBNet or PowerShell or something to query the database or to have some type of data storage, which I'm going to end up using MongoDB in this particular case, and to query that and provide different reports. So kind of a lot of functionality that I wanted to do with it. And so I had built a number of programs and had been working on some previous programs, which I'll come back to in another video, regarding the callout manager functionality of IPControl, where you upload files and process these. Well, I took that same type concept and started to build an application, and I think that anybody who's working with MongoDB, maybe working with the nodes and dealing with functions or external API, templating, etc., might find this interesting if you're running into the same type projects or looking to do projects that require storage and an easy way to do that. So the first thing is I'm using the MongoDB configuration nodes that I've installed on my separate Node-RED. So this is not the cloud automation appliance. This is running on my Linux server. And I would suggest if you have a lab and you want to do these and follow along, do this in a lab, do it on type of Linux install and follow that procedure. It's very simple. And you'll also need a MongoDB database. So on my same Linux platform that I'm running my Node-RED server, I also have a MongoDB instance that I created that just starts up. And then I interact with it via the RoboMongo utilities that you can download to manage the different collections and do reports, look at the different filter queries, and understand how the structure looks. So you're going to need some tools, and you're going to need some utilities to help you along the way. And I highly recommend RoboMongo. There's probably an updated version since my last time I've seen this. Node-RED, of course, and you'll need a server or MongoDB if you want to follow along with the Mongo functions. So in terms of this, if you're managing the palette, the first thing is you can go out and through the install of the palette, you can search for MongoDB. Just know that there are a few, and you may even need to work around with a couple of these. The ones that I've ended up using are the .0014 version, which I'm using for the specific Mongo functions. And if you open up this, it will show you the installation procedure outside of the UI through the settings, through the command line and npm that you can run to install this. So you'll need to have those prerequisites at least at a minimum. So go ahead and take a look at those. In terms of everything else, however, it should use the standard nodes, and we're going to continue through this function. And then the background of what this is and what I'm trying to accomplish is there's a new command in BIND DNS, as I mentioned, that is called DNSTAP. And there's a binary file that gets created through this DNSTAP that maintains the queries, the IP address of the client, the server, and the query and response. So from a security perspective and syslog, and for certain customers and environments, they want this type of response data, which is specifically available through DNSTAP. In most cases, we deal with the syslog forwarding and dealing with DNS query logs, but this kind of does all of it in a single process and also does not take up any of the cycles around DNS specifically in terms of capturing the data. It's more like a sniffer and a low-level, low overhead function. The files of these grow very large though. So what I found was, as I was growing this and collecting the data, that I had to start injecting multiple processes to limit the size of the data file. So anyway, to kind of go over this process, and I'm going to show you the process in the back end where I'm uploading it, and then the different reporting that I'm doing for these, and try to keep this within a time limit. So the first thing is I created a post function that's going to accept an upload file. And effectively I'm going to call this DNSTAP. And on my DNS server, and specifically on my Sapphire appliance from BT, they have a command called curl, so they have the curl commands that I can use to upload, and I've created a couple scripts that will effectively allow me to do that. And what it's going to do is, every 2 minutes I have mine scheduled. Yours may have different mileage and traction, but every 2 minutes I'm going to run a command called DNSTAP-read that pipes out all of the query details into a file, and then it's going to perform a BIND DNS RNDC DNSTAP rollover for the log files. So it's going to roll these and support up to 24 different logs, and it's going to effectively use curl to upload that small file every 2 minutes into my curl, or using curl into my Node-RED workflow. And I'm then, through this workflow, when it calls it the DNSTAP, I'm going to read the file in and process it and store it in MongoDB. So in that upload command, the way that I'm working with curl, it's pretty straightforward to do. This is the command here. I won't highlight it too long. But you're effectively telling it the curl-k, skip the certificate check, -ace for silent, S for silent, excuse me, -F for file, and you'll need to have the file format, which I have set up in a variable near the top, which is going to, well, actually here, that says data equals your @ and then your file name, either through variable or through a full path. And then the URL of DNSTAP. And when it uploads that, I then send a response back, which is read here, and in that response I tell it that the result is 0, meaning I received your file, and I immediately respond to the client. The rest of this should be processing behind the scenes, and I don't want to hold up the end process since it is running on a DNS server. So the first thing is, there are some simple commands that you can run to parse a string file, basically, that comes in. And these are stored, the file is actually stored in the message.rec.files, and if you have multiple files, it's in an array structure. If it's only one file, it's 0, and then you can do .buffer.toString and open paren, single quote, UTF-8 for the format, single quote, and then close paren. And so you can use the JSON expression editor to create this string and tell it to go ahead and read this, and when in so doing, it feeds it into the payload. So I'm basically reading this in. And I had started this process on my server by doing this with a very, very large file. It is well over 2 gigabytes, because I've learned my lesson of starting small and growing, and it doesn't work that well. So you might want to start big and work your way backwards to figure out all the workarounds you're going to need to do in working with very, very large files and structure. Same thing with my DNS version of the log reader, my VB utility, which I'll pop into sometime. Well, anyway, I read the file, store it into the payload, and then what I'm really doing at this point is just parsing this out and allowing me to then format the data into a JSON structure that I'm then going to push into a response that is then going to be fed into the MongoDB one record at a time and inserted and saved into the database. That's all I want to do, and that's all I should do, is handle the data structure and store the data. So the first thing is I'm going to go ahead and create a variable to store the records, which I'm splitting on a new line. So notice the dot split and then the \n. I'm creating a couple of arrays, and I'm going to store the responses in the data to, and then I'm reading through the records and parsing out the information I want. I'm then going to create a new structure called response, and based on that parsed data, I'm going to go ahead and then create a new structure which I'm going to feed into my programs, where I'm going to reference these by name. Okay, so this will then become my structure in the data. I'm also going to specifically call out the client IP and the server IP, which we're then going to later split out the port number, which might be important to you. It's not to me, so I stripped it out. So in this response, this was what we're going to store, and then I'm lastly telling my DNS server that I want to log all transactions, and I'll go into that configuration shortly. But in that configuration, it says all transactions, and that means that there's going to be the client, which is CQ and CR for question and response, and then the forwarder. There's also resolver and a couple others. If you're not interested in all of that, you might want to change it. And like I am, I'm only interested in the client and the forwarder and returning the response and capturing that data. So I'm putting in a if check here to pull this out by its type that I stored in my new structure. And if it does meet those, then I want to go ahead and add the resource record type of this entry, which I'm later going to use in my queries for calculating of record types as a general overall summarization. And I do the same with the client IP, where I split the colon and then take the first array element, and the same with the server IP. This all then gets pushed up into this array, which I then turn and return back to the message in the payload to be processed. Each one of those records, so there could be tens, hundreds, thousands. I found at 2 minutes on my server was 200-300 at a time. On a busy server, expect it might be 10,000. So as I mentioned, you're going to need to maybe scale this ahead of time. But for your home, and let's say you're doing this for a home project like I am, this just gives you this ability to do this quickly. So I'm going to use the split nodes, which are available through the standard nodes of Node-RED. And two things I'm going to do. I'm going to do this kind of in parallel. I'm going to join this information back, and I'm going to make a debug mode in case I ever want to see what it looks like. But through all this process, I really don't care what happens after the split, other than I want to tell it to store the data as a save in my DNS queries collection, which I designed for my queries. So in this collection, my local server, I have these DNS queries, and basically what you're going to see then is each save, it creates the ID for the insert, and then stores the data that we're telling it within this structure in JSON that I can then query and pull out of the server. So all of that was real simple to do. There wasn't really a lot of processing in terms of storing the data, which I like about this MongoDB, and the speed and the performance and the ability to manage the documents with NoSQL. But because I'm not a MongoDB expert by any means, I'm relatively a novice, give me Google, give me a working example, and I'll give you something that works. That's where I go with this process. So I figured a lot of this stuff out through trial and error. So the next thing I wanted to do with this, I found, well, okay, so I've got this working. I have a script which I run, and it's set up in my cron to do this process, to run that script every 2 minutes, which is set up to run the script and parse it out, to a file. I'm also writing within my script a bunch of logging information so that I can see from an administrative perspective what the date and time and the success of these logs were, and I can see this historically. It'll also give me indicators like the number of records and so forth. And as I expand on this function, I'll probably add in alerts. So if it doesn't process the file, I'll also put in a number of retries, and I'll also effectively put in that we'll modify and delete the cron if for some reason it doesn't and can't communicate with the server for any reason. So we'll have a kind of a graceful back out when I'm done with this functionality. That's kind of where I plan to go with this. But then when I thought about this, well, what can I do with Mongo? What can I pull in terms of the data? So the first thing I started thinking about is, well, what about querying the database and pulling information out, and how do I want to do this by default, and what should it read? So the first thing I started off with is some really basic node functionality that allows me to basically define CSS styles for HTML. Maybe come back to this in a second. I can also set up various JavaScript functions that are going to be embedded into the body of the HTML. And then lastly, it creates a template in HTML structure loading in that style, and then creating effectively the forms that we're going to see that now makes this interactive, that I can specify the filter effectively and have it reload and parse out the new details. So, creating an HTML form through Node-RED and making this interactive. So if you think about this in a long term, or in the long term, you quite literally could create an HTML application. You could wrap login capabilities around this, perhaps into IPControl or AD or some other source. There's nodes available. and other things that you can do there too. So it's fully featured, fully capable through anything you can do through HTML, you can do through Node-RED and these templates. Right? So the idea then was that I want to go out and do queries. And the goal then, as I started working through this, is to, I started off by simply giving me back the IP address of the client connecting. That was great, but that didn't work and give me too much information. So I wanted the ability to filter on client. I wanted the ability to have all IP addresses, to specify a month and a day individually and an hour within any of those criteria. So if I don't care about the month or day, tell it to do a specific hour. As an example, to see trends and analysis. To limit the number of records, setting a default is, I think it's 25 or 50, and then allowing you to specify 100 or 1,000 or what have you for the client you're using, and depending on how you want to see this data. And then also the ability to filter out on this memory ID, and I call it XID, but more memory ID, I think, for the transaction. And then what I calculated through the nodes, the type. So if I want to filter out on quad A, I can say give me all the quad A that occurred in this time and date, or by filters, and it'll give me those records and their various content. So I thought, okay, that's pretty cool. So within this, I then wanted to have that flexibility to just pull the data and monitor that. Right? So that's interactive. And to do that, I set up a very simple get URL endpoint called tap-queries. I'm feeding this into a function, and in this function, I'm doing a number of things that will go ahead and set any kind of default values for specific variables that I'm later going to use in this function to create a query. So I'm going to construct my query through either default values or through whatever user input is provided either on the URL string parameters list or through the form when they get to the log site. So the first thing is I want to set the limit, which I set to 20 to make it easy to use. I created a months variable that when I go out and tell it to get the date, it'll go out and pull the month, and I can pull in back from here the specific date. And the reason being is in the date structure, you need to kind of translate this back into its textual format short term. So this is April 2019 is how they store, Mongo does in terms of the data, and also how the DNSTAP is stored in this structure. So because I had a number, I need to return a month, and this is how I did that. I'm then going to set up the limit and go ahead and say that if there is a limit in the payload, which would be in the URL string or post another structure, that I want to go ahead and set it to whatever is in the client specified. Defaults and then client specified. Then I'm going to go into the current day, which I use a couple date functions to get the date. I then say and read if there's a current one through the payload, and then again set that. But a couple things I wanted to do then is verify that if it's less than 10, meaning single digit, there's probably a JavaScript function for this. The hard way is to compare the size or the number, and I'm adding the 0, but you may notice too that I'm also adding a caret to this 0, which I'm appending to the current day. And the reason I'm doing that is I'm constructing the query, which I'm going to use regex effectively, and it's going to look for the starting character from the start, that it's this character plus, or the start current day, which would be 10 through 30, 31. Same thing with the current month, reading the same details. With this, I then translate it back to its contextual method of it, or textual method, so I'm only using that to pull this through the months with that number. But I do have to convert this back 1, since we're working on a 0 array versus a 1 through 12 month. Now the client IP, I just went ahead and did a very, very simple regex of anything with a dot, so there's an IP address, and if there's not, then if it's on the command line, go ahead or in the payload, go ahead and read it, and set the value again with the caret, and do a regex for the IP address. Same with the else, and if it doesn't, we're going to go ahead and potentially check the request header of the HTML page, where I can pull the IP address of the client connecting, which made me think of a number of other projects that I can do with this that I might circle back around, and then kind of down the list even further. So getting into the hour, more values and more functions, reading in the various fields and payload, and then I'm getting down into the various things like the question, the XID, RR type. And all I want to do in these is I want to validate that there's valid data, anything. And this is what I found worked well with the regex. So now here's where we want to get into some of the functions that might help you if you're looking at Mongo. And that is the query structure itself. And I ended up having to do a AND function with this data, which was effectively ANDing a number of fields together. And so I turned on the debug so that you can see effectively this query since it's collapsed. And what it's doing here is it's doing an AND, and each one of the ANDs, you have to open it in the AND, $, and then it's an array of different properties and or test criteria that you're going to compare and AND. So each one must meet and match what you specify in the AND criteria. Okay. So what I'm telling it to match then is I'm telling it to match my date. I'm telling it to match the client IP, which I had specified. This one didn't have anything, so it's specifying a regex of anything with a colon in the time. Anything string, anything that's got a dot in it for a web or URL, and anything with a string. So this is what is effectively being ANDed in this query for MongoDB. And when it's done with this function, it stores all that information out to the payload, which is then we're appending a message.sort, which I'm telling it to sort by time, showing me the most recent entry, so the descending order, and to do the same thing with the date in the descending order that was determined in the earlier variables. And then also to set the message limit, which these two properties set in the message passed into MongoDB allow you to set those values and attributes and properties and so forth to perform the sort and limit. And then return the message. And that's quite extensive and gave me a real simple query to do the function. Now in that query then, I'm passing it into MongoDB. I'm telling it to go out and do, in this case, a find, which is a type, and I have a local DNS, MongoDB server. The results of this information are then being read, and I'm going to parse through this data, and I'm going to push this out to the payload. So it does send information like the ID and others, which I don't want, and some other attributes, but I want these returning in a specific order, and so I'm modifying and pulling the data I want in this order, pushing it into an array, which I'm then saying into the payload is going to be the array that I'm going to pass into the CSS script and then HTML. And lastly, I'm going to return this HTML and styles and script to the client. And that client then, when they connect to this, can specify in the parameter list all of the details. So if I wanted, I think, to a 6, I should be able to specify that. If I had anything within this particular date and time and other functions, be able to filter that data out. And same thing with the form. So I can have it load from the form and do this data. I can get rid of some of these values, look at the dates, look at the time, and see if there's any values stored. So a number of things here that we can work within, and then also the ability to go out and function by type and by question. And so what I mean by question, your query to be basically a regular expression of anything, so you can make it as long or short as you need. So I thought that was okay, and then when I was done with that, I wasn't quite excited about it. So I thought there's got to be some other things I can do, and now that I have a common template of how I want these things to look, I can go ahead and format this accordingly. So I thought, well, the next thing I want to look at is I want to look at a list of queries of types of records summarized by their type with a count. And I want the count to only be the client query, not the response, which I had in there previously. I had to fix that, so that I can only see the number of queries. And these are by type, and this is by the historical number since it's collecting the data. So, and to do that, I again set up another get function that accepted on the URL string pretty much nothing. So I'm building a query that uses an aggregate. And so in the aggregate is basically an array of commands and functions that are telling it what to do and how to return the data. So what I'm doing is I'm telling it to match the type of record in the data that's stored as CQ. So it's the match and the type as a property, and that the $EQ is telling it to equal CQ. This could be not equal, it could be other comparators that are provided through Mongo. It's then going to group these together, which is then going to specify an ID, which is going to turn out to be the RR type, or the resource record type, which is, again, is being pulled from the database that we set up to create that. And then lastly, it's going to sum or count this data, return a count of sum, meaning that it's going to count each of these records for us that are in the group. And then lastly, sort this in a descending order, showing us the greatest number of queries first, down to the least. And then return that to the query, which again with the other functions were passed into MongoDB. The MongoDB is again using, this time, an aggregate function. So if you're using the right mode, you should see find, count, and then it's an aggregate. It's then passing that into a CSS, which I just copied and pasted from the other. And then I'm telling it through the HTML to go out and parse out the data I'm interested in. And in this case, it's just the ID and the count. Pretty simple to do. And I thought, okay, so that's pretty exciting. So I get now a summary of data. I get the ability to go and query anything I want historically. And then I get the ability to see the summary of the records and data, which I ultimately want to have an API to call this. And then I'm going to create a dashboard that I have actually I do. I have a Raspberry Pi that has a touchscreen on it that I want to have kind of a dashboard that shows me the stats of my DNS server. If I then get any errors, if I get things like that, I want it to be able to report. And so I'm going to be able to capture some of this data, and that's what I'm working towards. So that's where my goals are. So this is just kind of a simple way of getting at the data and pulling the data out. And then lastly, I had a thought about, well, there's also IP address data that I'm pulling from the client, which I felt, well, with the client data, maybe I can do some things like pull out what the DNS is, what the IP is, and then look it up within my IP-controlled database in my lab to see what IP address, host names, and other details are registered to the device to make the details more user-friendly in a visual sense by looking up the actual IP data that's stored in the corporate database. In this case, my lab. So the tap IPs is, again, just a get function. And in this particular function, we're going to do, again, a aggregate query, pardon me, which we're going to match the type of the query, which is again going to be CQ, and group it by, this time the ID is the client IP, which is what I want to be shown in the list. We're going to again do a count, which is just a sum of 1, and then a sort in a descending order. And again, that's very simple to do. And then I can go out and put other types of match criteria if I wanted to filter by date or time or some other functionality. I wanted everything, because especially with the IP addresses, and whatever gets passed into that, I can it tells it to aggregate and format it. So the output of this is going to be an array that I split, and then I thought, well, let's hook it into the IPControl database. So the first thing I needed to do is I need to kind of change around some of these parameters and build a string that's going to tell it what the URL is with the IP address populated, so that I can query the get device by IP adder API directly from my database. All right, so I'm making an HTTP request into IPControl through an API to do this function directly from HTTP. So what I need to do is it takes, in terms of, if I look at the documentation, it takes a payload of IP address, and in the return of this, you remember I did the storage as an ID. So whatever gets split in there is stored as ID, and that's how I pull it out. So I'm then going to move that into another variable so I can later see it, and do the same thing with the payload count. Then I have some headers and tokens which I'm going to use throughout this process to provide a standard login, because this is kind of unattended. So I have a specific user, a specific token that gets run on a frequency of 30 minutes to generate a custom token just for this process. Okay, so I have a custom user for this. And that JSON expression builder is where I'm building this URL string that's going to be passed to that function, and I'm taking out the message ID from the packet or from the payload. Okay, pretty straightforward. Then it passes it into the HTTP request with the GET. I enable my SSL and I have the specifics, and I want it to return a parse JSON object. And so a couple of things I do here is I go in and check if there's any fault. And in IPControl, if I cannot find the IP address, we're going to generate a fault string, and that only occurs on an error. So if it's not an error, I have an error, send the output to the output 1, and if it is null, there is no error, go ahead and process further. So in that particular function then, here's 1, so it's an error, and what it's going to do in this particular case is strip out some data and basically minimize it, remove it, move the count back into the packet information, so at least I can read the IP address and the count because I don't have any IP control information. So it's just kind of restoring the default view and moving that data and deleting some of the faults. When it is found, I'm then going to move that information of the ID and the payload into the returned device JSON. So it's now the device plus these headers or variables in now the payload. Then I'm going to join all of these back into a single array, which then gets passed back through CSS, and lastly through HTML, where I can parse out again different headers, and then I'm pulling in through the mustache syntax the various fields from the payload array. So reading the payload as an array, which is kind of using the ngNext to navigate through the properties. And that's it, and it sends it back to HTTP. And so now every time I load up my screen, and this just does it by default every time, it goes and pulls the IP addresses and queries the IP address. If there's multiple IPs registered for IP, because it might be multi-homed, it's pulling out all the interfaces, and then all of the MAC address interface MAC addresses tied to those. So going a little bit further, and I also have, if you've seen any of my other videos out there about the MAC address vendor, I have in my database a script that goes in and compares the MAC addresses to convert it to their vendor string. So now that in the description I can see the types of devices, and that then gives me an idea of what kind of devices are querying my DNS. You know, maybe there's something you don't want there, or it comes from a region of the world that we shouldn't be allowing. So some interesting things. And if you're like me, you kind of get into, kind of experimenting around with whatever, tools or things that you have access to. So that's kind of some of the things with the details. And then in terms of the DNS setup, for those who are interested in how that looks, and I'll show you how we do it, the DNSTAP setup in BIND. In our DNS configuration for the newer versions of BIND DNS, there are several specific options when this loads that allows us to specify, I'm sorry, I'm on the wrong server here, allows us to specify the file and also the location of that file. And let me get my server loaded here. This is kind of my quasi-production, if you will, just something I keep running for configurations. And in my server here, where I'm managing my DNS, the options then for the DNSTAP are specifically in the DNSTAP. And within the options of the packets, what type of messages you're going to collect, it can either be all, which I'm doing, because I may want to pull out some auth data, some resolver data, and I also may want to pull out some of the forwarder information, which I'm parsing out. But you can filter this down to any of these particular categories, like just the client. I'm going to do all for mine, but eventually I may return to this. And then you can either say it's going to collect all the responses, query and response, or just one or the other. So these are explicit of each other, or implicitly denied of each other. Explicit of each other, excuse me. And then the DNSTAP also allows you to specify identity, could be a number or a name. And then lastly, where your file is going to be stored, or whether you're going to use a Unix socket. Now, I'm not familiar with the Unix socket yet, so I use a file. And in this file, it's then going to store all of this into a standalone file when I push the configuration. So remember, you'll need to deploy the configuration change, which you can do through the management DNS configuration, and either configuration only, or if you have a setup task to do that, to deploy the change to your server. Make sure you do last known good and stop on critical errors if you have those options. And then once it's complete, it'll store that information within the tab file. And then within the RNDC commands of bind, there are several DNSTAP functions to roll the count and to reopen a closed file in case it was truncated or others. So if I had a backup, I can reopen the file. So these are some of the options, and this is what I'm calling in my script to roll the log. And the reason I'm doing that is I only want to capture that window of times queries to make it processing capable in my server without overburdening the server. I don't want a billion records every time I do the process. So that's effectively what's happening there, and it should work very well. And then in terms of reading that information, bind includes a binary file command called DNSTAP-read, which specifying the log file, let's just do 0 here, will parse out that information to the server so that we can read the data. I'm not sure. Message file. Oh, my apologies. DNS bin, DNSTAP read, and then DNSTAP tap 0. So then we're getting the output again, as I mentioned, in the format, and this is just very minimal structure. So just the response and the answer, server client. That's all this is, and that's what the default is in terms of reading. Now, if you're troubleshooting and you're an engineer and you're going to get into reading more of this information, you can help this and you can pull out what the other attributes are. And you can do things like trace the memory if you have the tab file. You can also do things like print the full DNS message, which literally prints everything that's out there. And then further, you're going to have the ability to do a YAML format in the output that you might want to pass into some other function. So that's where I'm at, and that's kind of the custom project. Sorry for a little bit of interruption there in my IM, but that's where we're at. And I hope that you have gained some insight at least into some of the Mongo things, which is really a great way to structure this. And then also keeping your mind on the template capabilities of Node-RED and the ability to build these workflows that are asynchronous in nature and run in the background and can help you do certain programmatic things to help you along the way in whatever job you're doing. And so I'm going to build an API out of this that I want to put into my VB.NET program and my logger and kind of build this functionality into it and have it query this. And I'll come back at some point if I get anywhere else or move along with this to show you that information. So thanks for your time. Really a long video. Apologize. And feel free to leave me any comments if you have any questions, and I'll try to get back to you. Thanks again, everybody. Take care.